Hello, this is Robert Gadarian, and today we are talking about for loops. And eventually this week we will talk about files and how the two actually work together very nicely. But for today, this slide deck, we're going to talk about using a for loop, using the syntax. Of course, there's new syntax. I think I would make that joke in the slides. I already just jumped the gun. And using range and for together to do a certain number of iterations. So the key here is, with for, is that we're going to do repeat code. And we've repeated code. We have the while loop. So why do we need a for loop? And what the for loop gives us is the ability to iterate over something that has a certain length. And it'll run your code that many times based on how many elements are in this thing. And for now, in the slides, I say it's a thing because what it's called is slightly beyond the core scope, but it's called an iteratable type, which is literally something we can iterate over, and Python knows that it has a certain number of elements and that we can access each one. So this is the syntax. For a line in my file, and we'll be doing that later on, we can print a line. So the important thing here is how we're reading this. And what we're looking at is for something, run this code. And for each, in this case, it's each line in this file. We're going to see each character in this string, each item in this list, each key in this dictionary. We're covering dictionaries in about 2 weeks. And as long as we know what we're iterating over, we can just repeat this code very easily. I've already mentioned that, well, we already know how to do this. We know how to iterate. Well, we saw the while loop, so why are we learning the for loop? This seems redundant. Well, it is. But they have different uses. Kind of like a truck and a car. Well, they're the same thing. They move my butt from wherever I was to wherever I want to be. Well, they're good at better things, good at different things. A truck is good if you want to put a huge box in the back, put a motorcycle in the back, put a refrigerator in the back. A car is better if you're moving things that you probably want to keep dry. So two things that have the same purpose, but exceed at different aspects of what they do. So for is good for a fixed number of iterations. Python has a weakness with for, and I actually don't like the for loop in Python, but it exceeds at doing a fixed number of iterations. So we know it's going to run 10 times, and this data set is 10. It'll run 10 times. It'll run no more, no less than 10 times. Once we have these sequence types or iteratable types, we know that we can iterate over every single item in this set of items, which is nice. While, on the other hand, is good for an unknown number of iterations. So we saw this with cleaning data. We have a program that we want to ask the user for a bunch of numbers, and we'll add up all those numbers for them, but we don't know how many times we're going to get numbers from the user. It might be none. They might just quit, and the sum of no numbers is 0. They might give us 1,000 numbers. They might give us 2. They might give us 100. We don't know. So while is really good at that. It's like, while the user's still giving us something good, keep running this code. For loop would not be good there. Even consider the case. This one's tricky. We want 10 good inputs from the user. Well, if all users were useful people, it would be a nice for loop. We know that we want to run this 10 times. But users are hopeless monkeys behind keyboards. So we have to check the data, and we might have to run this loop 1,000 times, 1,000,000 times before we get 10 good inputs. So that's actually a while loop. So that's the difference. While is good for unknown number of iterations. And basically, when we keep on asking that question, should we keep running? Should we keep running? Versus for, here's our set, we're running 10 times, ship it. An interesting point, all for loops can be written as while loops. And in terms of your computer, well, for loops don't exist. Even if you're writing in a different programming language that's not as fancy as Python. Python is a high-level programming language. There's low-level programming languages where you're basically writing computer code that is that the processor reads directly, which is not what Python is. Only while loops exist, which is interesting. You can cover that later. And second year, 2280, you get to talk a bit about that, which is really, really cool, actually. Okay, so for loop. For variable in sequence. Variable gets set every time in sequence, then the loop ends. Okay, well, this is confusing. Let's actually look at code. We need a sequence data type. Well, good news, everyone. A string is a sequence data type. So I can have a string. I'm going to name it the input, because I'm going to change this to actually use input eventually. Well, hello there. You don't come here for spelling things properly. In this class, you don't have to spell it right, you have to spell it consistently. And I'm going to say for letter in the input. And then it automatically indents for me, meaning that there is a code paragraph here. And we've seen code paragraphs. This is not a new surprise for us. This is not a new concept. We saw this with if statements. We saw this with for, while loops. And now we're seeing it with fors. And I'm just going to happily print this. And I'm going to print it in pointy brackets, just so it's kind of pretty. Letter. And I'm going to use string appending format. Again, know how to do one of them. Know how to read all of them. And then print. Done. Okay, there we go. So if I ship it, what happened? Well, by the way I wrote this code, you can tell what I knew was going to happen. What happens is it takes this string and gives it to this for loop in the input. Then this for loop is going to go through each letter one at a time and run it through my loop. So in terms of how this might look, we have hello spelled correctly. Hey, that's nice. Hello spelled correctly. Imagine that. And we know that these are all indexed 0, 1, 2, 3, 4. We know that we can slice them, and we know that we can do some other cool stuff too. It is going to take them in order. That's actually really important. If we can't rely on this, our programs fall apart very quickly. It's going to use this first letter, so really index 0 of the input, the first time. It's our first iteration. Okay, and that is going to be set to what I said is my variable of letter. So that is why I named my variable that. I could name it anything. If I jump back to my code, I could say for Rufus in the input, terrible variable name, and that's what I'm trying to drive home here. It'll work the same way. That variable name is for us. But we know that whatever variable we have here is going to get each element of the sequence in order one at a time. So first, in our example here, it'll get H. And guess what? The second time it runs, it will get E. And the third time it runs, it's going to get L, and then another L, and then an O, and then it'll be done. So we know there's a fixed number of iterations. In this case, it's going to run 5 times, which also happens to be the length of this. We call the variable the input. It'll always be the same as that, which is handy. This is an aside, in other programming languages, we actually see these differently. If you take 1020, you're going to see this. This is how Java does it. This is how C does it. This is how C++ does it. For int I, semicolon, I is less than, I'm going to call it str.length. and I++. So this is how I see a for loop. And this is the instantiation or initialization continuation increment. And then we can actually do some cool stuff with this to make it run fewer than the length number of times. And we can kind of recreate this. And we're going to use range to recreate this. This is everything else. Python is special. And in terms of what it's called, the for loop in Python is actually a for each loop. And it's really nice to see that in code. We can actually really say for each letter in the input. And do this code. And that feels really good. And I guess that still runs the exact same way. And we can see how many times it runs. And we can run any code in here. This is a code paragraph. There is no limitations to what we can do. So I'm going to have a counter spelled, I need to fix it. I can't live with that. It starts at 0. And each time this runs, we'll count it. Rand, D times. I'm so literate today. I love it. Dot format. And we're going to pass it counter. Apparently I could have left it misspelled. I misspelled it the same way both times. Now that counter ran 16 times. Perfect. How many letters do you think I have in this string? I'm going to guess it's 16. Hey. Oh, no. Let's see. I could actually do it in my interactive browser. I could say length, or len, of the input. 16. Nice. So we know there's a fixed number of iterations. We can predict exactly how many times it's going to run, and it's kind of great. So let's keep on going. What we're going to move this to is we're going to have some kind of data set. And this is kind of the future state, where it's going to be a string of probably objects, and whether it be a list of strings or a list of something else. And inside of this code, instead of running some simple counter and printing out stuff, what we want to see is a function call in there that's going to process data based on this function. And it's actually a very powerful thing. That's where we'll go eventually, and something we can do with these for loops. Code paragraph, again, we can have anything in there. There can be comments, as long as they're still indented. Very complex mathematics. We could do a power series. Ooh, flashbacks to math, where we have some kind of fraction plus another fraction plus another fraction that's an infinite series. And we can calculate the first n of these. And we can even prompt the user for what value of n in this power series, how many of them would you like to calculate? And that's pretty cool. But sometimes we just want to run a certain number of times. So this other for loop that I showed you, that's the Java, C++, C version, we give it a number to say how many times we wanted it to repeat. And what we'll do is give it the length of a word and say, repeat this many times. So for people who've programmed before, again, not an expectation in this class, this might feel more comfortable. Or maybe your brain just works this way. So why not? What I'm going to change this to is get the length of this string and repeat this loop that many times. So first I'm going to make a loop that runs n times, where n is the number of letters I have. And that is where the range function comes in. So for, I can't help myself but call it I. This is a very normal programmer thing for running something a bunch of times, and this is our loop counter. For I in range, I'll first do it just 10 times. And then I'm going to say print I, which will happily just print out a number. And it starts at 0 and goes up to n, not including 10. Does that sound familiar? Yeah, That's how we do almost everything in terms of counting and numbering things in computers. And that works really well for this. So we know that the length of this string, the input, was 5, which is fine. So if we wanted to run a loop 5 times, we can use this, and it'll give us the indexes 0 up to and not including 5, which would be perfect for creating these. So given this code, I can create all the indexes I want, or indices if you must, to get each letter. So I can say, I'm going to change this to be n, because I don't want specific code. I want general code. And again, you can see that on line 3 right here. That's the only input that I have, and I will change this to an input statement eventually, or you can do it if I get distracted and forget. Length of the input. So that will be for I in range 16, meaning it's going to create numbers 0 to 15. So number 0 up to and not including 16. Again, think about this as just n. If you think in general terms, this course gets very easy. So print the input at spot I, which will literally, this one. It's going to give me 0 the first time. I'll do this in green, giving us H the first time, then E the second time, 2 the third time, 4th time, 5th time. Click, 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 click. Slowly moving through this string 1 character at a time, eventually getting through the whole entire set. And I print out the numbers and then the letters, so you can say it says hello there or hello there. So you can see there is here. Where at spot 11, I have a T, spot 12, I have an H, 13 is an E, 14 is an R, 15 is an E, and then my loop is done and it exits. So that feels a little bit more like traversing a string if you have seen a programming language before other than Python. If you groove on this, awesome. Use it all the time. If you don't groove on this, fine. Use the other one. But I want to show you how to do it one more way. This course is all about choice, as it turns out. Let's do this with a while loop. So I want to do pretty much the same thing. Counter is equal to 0, while my counter is less than the length of my input. Keep on going. So I'm going to go through by index, starting at 0, and go all the way up to n, and not including n, so that strictly less than is going to save me from that. Do something. And I can do the exact same thing, which is a little bit ugly. Maybe I'll print them on the same line this time, because that's, you're going to find you do this too, where you know that you could actually probably type it faster. Oh dear. And then you copy and paste and waste a bunch of time because you're saving time. There's a saying of, save so much money we go broke. This is kind of that. I don't know if maybe that's just an old person saying. I've never heard anyone under the age of 50 say it, other than myself. A nice thing Spyder does, you can see it actually lights up the brackets. That's a very good visual reference to make sure that you have matching brackets. Uh-oh. I'm not mad. What did I do wrong? So as it's printing out 15. Oh, yeah, counter equals 0. While counter is less than... But that's a problem. I can show you how to quit a program. You click on... Here, I'll switch over to full window. You click on this stop button. Click. And it's super mad at me. So... what I need to do, I have a couple bugs here. There we go. I don't want to use I want to use counter, first of all. Copy and pasting code, never worth it. Now it's going to run something else, infinite number of times. W. Okay, well, that's not great. That's because, why? I'm not incrementing counter. Plus equals 1. Counter is equal to counter plus 1 also works. And that'll count all the way through it. So here is me starting at 0, printing out a letter, go up by 1. Is this still within my loop? Okay, do something. +1. Is this still within my valid range? Okay, print it out. +1. Is this still within my valid range? No? Okay, break out of here. Print. Done. This is actually not the worst thing. You still have to do the prime the loop thing, where you have to say, we start at 0. Is 0 within my valid range? I know it's going to be the first time, unless this is a 0 length string. And then run this. Add 1. Are we still okay? Go, 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 go. While loops are very repetitive. Get used to thinking that way. Other ways to use this are giving start and stop points. So I use that first version of it where I just have range stop, where it goes up to and not including whatever number you have. I can, Python might have changed this, list. I don't like having to do this. This is something I don't like about range. Range of 10. It's going to give me all the numbers up to a 0, up to a not including 10. I can also say 2 to 10, and it'll go from 2 up to and not including 10. What happens if I say, having issues? Oh, why are you not letting me press up? I have to type it again, like an animal? Oh boy, copy and paste time. Wonder what I pressed. 10 to 10. What's that going to do? It's going to start at 10 and go up to and not including 10. Empty list. That's a list for, we'll talk about lists in a sec, but this is just the data. What about 11 to 10? Nothing. So it starts at 11 and goes up to not including 10. Well, we're already beyond that, so it doesn't give us anything. But we can use the last element, which was step. And we can step -1, so it would count down. This is ugly. To that number up to and not including it. So if I want to count from 11 down to 0, I have to give it -1. So it get all the way to 0, print out 0, and then quit. I can also count by 2s, which is kind of fun. I don't know. I think this is somewhat compelling. If I'm a very even person, whoops. You can count it by 2s, 10s, 15s. Not a super useful tool, but it's kind of interesting. This is a lot like slicing, where it's got a start point, end point, and a step. And we saw that last time, even with the meme that print out pi backwards, and they just use the back step to do that. Silly jokes, actually get to learn something. It's all good. All right, nesting loops. This is interesting. We can put for loops inside of for loops. And it's not totally obvious why there's no reason why we'd do this in terms of drawing, other than to just show you what's going on, and so you can prove to us that you know what's going on in loops. And this is interesting, where we want to print out a bunch of stars. So say that we want to print out stars in a box that is sized 3 by 4. And really what we want to eventually get to is to have n by m sized. Again, we will always take the next step to be general. Always have your variables up top, and then you have general code that can solve all the problems. And we want to do this with for loops. Otherwise, we can't generalize this problem well. Well, we have to break this problem down into a way that we can solve it with for loops. So what we're going to say is, for each line, this is really first. Oh, that was very nice. To print out n stars. I might change the meaning of m and n because I'm not super happy with calling this one m and n, but they're variables. It doesn't really matter. A and b. So this is obviously a for loop. I even use the word. This can be a for loop because we're going to look at a loop and print it out, run code n times. And we're going to run a print statement n times. There is a little Python trick inside of the definition of print. We can say what the line ending is. By default, The line ending is actually a new line. It's like hitting enter. But we don't want that because we want to print out things more than one on a line. So we're going to say that the end is an empty string, which pretty much gets rid of that new line stuff. This is some icky code. I don't really like it. Memorize it. I hate saying that. At least be able to read it and know what it says and know where to look it up, because perk of being online is that you can look it up. So over in my code land, I'm going to make a new file. And I'm going to save this as shape. And I'm going to say n is equal to 4, and this is the number of lines. So I'm switching the meaning of m and n. Enhance. And n is 3, and this is number of columns. So I want to run, looking back at my thing here, this is my outside for loop. So I want to run this. I need to fix this. It's driving me mad. N times. Okay. Well, we know how to do that. We just saw that in the previous slide. This must be a meaningful example. For, doesn't really matter. This is some Python stuff. In range n. That is the, I don't care about my iterator value. You can do an underscore. You could also just say row toe. Sure. Doesn't really matter. It's weird that just worked. And then inside of that line, let's just think about this one line. I try the problem of print m stars. Can you solve that problem? Let's maybe solve this problem first, and then we'll get back to the outside for loop. So I'm going to comment this out. We will get there. For column in range m. Well, I had some code that seemed meaningful. Print a star and end is equal to nothing. Empty string. I'm going to use single ticks. I'll use double ticks. It's a little clearer. Beep. Hey, I just printed 3 stars in a line. Well, I just solved this problem. Print out m stars. Now I want to have this problem solved n times. I want to have 3 stars, 3 stars, 3 stars, 3 stars. So, well, I know how to do the 3 stars. That was trivial. So let's do that a bunch of times. Spoilers, I'm going to do it wrong the first time. Intentionally. Well, I have this code. If I just indent this, I'm going to highlight and press the tab, and it indents the whole dang thing. It's going to print out, it's going to run this code n times. Uh-oh, that's not right. But how many stars do we have? Do we have 12 stars? This is a fun trick. Highlight, s is equal to this stuff. The length of s, 12. Okay, well, I must have forgotten something. So let's look at our little algorithm here and think about what it is. I want to print n stars and end with a new line. Oh, I missed the new line. So I printed out 3 stars, and then 3 stars, and then 3 stars, and then 3 stars, and that was all one line. I missed having a new line. That is a very small little subtle thing, but it certainly matters when it comes to this. So let's go back, and I'm going to comment this out. I want to print 3 stars, or m stars, and then I want to print a new line. So that'd be here. You're going to just say print, and that'll work. And then I'm going to copy in this again to make sure that that actually works. So I'm going to manually make my box in the stupidest way, and I have seen people do this on tests, and they have not gotten a good grade because it's not general. I know I could hit paste 4 times. Hey, look, I made my box. Can you make 5 rows? Yes, let me change my code and run it again. No, let me change my inputs. So there you go, I made my box. So what I'm going to do is I'm going to get rid of this again. And my little algorithm is for each line, print out a bunch of stars and a new line. So this print happens after this runs m times. So first row, print out m stars, new line. Print out another m stars, new line. So you'll see that this is inside the outer for loop, but not the inner for loop. And that will give me this box shape if I click the right button. If I want to change the number of rows and stuff, all I have to do is change my inputs, and I'll change my shape into what I want it to be. In class, we're going to do a few more examples like this, so buckle up. It seems really silly, but it really drives home what a for loop does and what each element of a for loop does, especially with that nested for loop. Knowing that that print is on inside of the outer for loop but not the inner for loop is very subtle and is very important and pretty tricky. I hope you're having a good day. I'll talk to you later.